Section 6.4, number 17, we're going to solve this equation using identities. So the first thing I recognize here is that 1 plus cotangent squared can be reduced down to cosecant squared x. Not changing anything else, so I'll just go ahead and copy that stuff down. And then let's get everything into terms of cosine and sine. So I'm going to rewrite cosecant squared as 1 over sine squared, and write cotangent squared. I'll go ahead and circle that in blue and write that one in blue as that would be cosine squared over sine squared. And that is still a giant fraction. That equal to 2, but that simplifies. We have a common denominator here of sine squared, so those will cancel, and I'm left with 1 over cosine squared x equals 2. So, I'm sorry, cosine squared, right? So, and then the square root of that, let's see. Let's take the square root of both sides. Actually, let's see. Let's rewrite this without the fraction. So if I cross multiply here, then I get 1 equals 2 cosine squared x, which will give me 1/2. So cosine squared x is 1/2. And taking the square root of both sides gives me cosine of x equals to plus or minus 1 over radical 2. And I'm going to change that to, I'm going to rationalize that so it matches up with my unit circle. And I get, so I multiply by 1 in terms of radical 2 over radical 2 to give me, on the right, I will now get plus or minus radical 2 over 2. And when is cosine of x of that equal to that? So I'll take the cosine inverse of both sides now. And on the left, I'm left with x. And on the right, cosine inverse, like within our unit circle, because our domain is 0 to 2 pi, cosine inverse is going to be, when is it positive or negative radical 2 over 2? So I'm looking for all cosines. So that would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that is my entire solution.